Hello everyone, my name is Kyle Tasker. Today for my topic of interest for the national issue, I will be talking about the Gulf of Mexico dead zone. What is a dead zone? So a dead zone is caused by excessive nutrients that are deposited into the water bodies. There's often high algal growth and high depletion of oxygen. This is also referred to as hypoxic. The aquatic life that lives there will either move away from the area because of the lack of oxygen, or it will stay and end up dying. The numbers of hypoxic water bodies in the U.S. has increased 30-fold since the 1960s. This is thought to be because of the high use of fertilizers in today's modern agriculture. This illustration shows on a global scale the areas around the world that are affected by hypoxic zones. In red are documented hypoxic areas, and the yellow dots are areas of concern. In this image, we see the three main contributors of eutrophication in water bodies because of the input of excess nitrogen and phosphorus. The process of eutrophication often benefits algal communities and cyanobacteria that rely on the high amounts of nitrogen and phosphorus and sunlight to create large algal blooms that can suffocate out other aquatic life. When algae of an algal bloom die out, they sink to the bottom where denser salt water occurs and coat the bottom layer of the ocean, causing sedimentation and restricting habitat for marine life. As many of us know, the Gulf of Mexico suffered a tragic accident in April 2010 when the BP oil spill occurred, spilling out more than 60,000 barrels of oil per day. This single event was the biggest marine oil spill in history. The Gulf ecosystem is in a very fragile state because of the BP oil spill in 2010 and also continued effects from the hypoxic zones that continue to grow along the Gulf Coast. The total hypoxic area can vary year to year by the available nutrients that come from the Mississippi River and drain into the Gulf of Mexico. The latest area that I've found says that the current hypoxic zone is 5,052 square miles. This map shows the watersheds throughout the United States with the highest potential of soil pesticide and nitrogen runoff. As you can see, the area of the Mississippi River drainage basin has the highest concentration of soil and pesticide and nitrogen runoff. Areas of the Midwest, including Indiana, Illinois, and Ohio, that are producing high crop yields are the same states that show the highest estimated nitrogen export by runoff per year. The issues that we have with current agriculture are that because of high demand of ethanol, farmers opt to grow corn to get the most monetary value out of their crops. Corn demands high amounts of nitrogen and phosphorus to grow, and farmers tend to over-apply fertilizers to meet the plant's needs. This is an interesting image that highlights the entire Mississippi River drainage basin and the rivers that flow into the Mississippi. The areas in light green are the areas of agricultural runoff, and the areas in bright pink are the areas of impermeable surfaces. This image does a good job of showing the total area of hypoxic zone within the Gulf of Mexico caused by the high influx of nitrogen and phosphorus from agricultural runoff. Runoff issues of point sources and non-point sources are a large contributor to the excess of nutrients into our waterways. We can see in this image that the percentage of surface runoff grows greatly, varying from good ground cover, fair ground cover, poor ground cover, bare ground, and concrete and impermeable surfaces. The Gulf of Mexico is a large economic driver for the coastal region of the United States. The 5 Gulf states have a gross domestic product of over 2.3 trillion per year. 72% of the shrimp, 66% of the oysters, and 16% of the fish the nation harvests comes from the Gulf. This region faces significant challenges not only from the recent BP oil spill in the hypoxic zone, but decades of degradation of coastal erosion, pollution, and overfishing. The Harmful Algal Bloom and Hypoxia Research Control Act was passed by Congress in 1998. This act reaffirmed and expanded the mandate for NOAA to advance scientific understanding and ability to detect, monitor, assess, and predict harmful algal blooms. A 2006 study showed that the economic impact from a harmful algal bloom event in U.S. marine waters averaged to be $82 million per year. However, just one major harmful algal bloom event can cost local coastal economies tens of millions of dollars, indicating that the nationwide economic impact of harmful algal blooms is likely much larger. Stemming from the Harmful Algal Bloom and Hypoxia Research and Control Act, the Hypoxia Task Force was formed. The task force was established in 1997 and conducts 5-year reassessments of the current state of hypoxia in the Gulf of Mexico. The 2001 Action Plan describes a national strategy to reduce the frequency, duration, size, and degree of oxygen depletion of the hypoxic zone of the northern Gulf of Mexico. Within the Hypoxia Task Force, 2 teams were created: the Management Action Reassessment Team and the Science Reassessment Team, to undertake the initial compiling and updating of the data for the reassessment. In 2006, the EPA requested that a Science Advisory Board conduct an evaluation of the complex scientific and technical issues affecting the causes, location, magnitude, and duration of the hypoxic zone in the Gulf of Mexico, as well as the priority and feasibility of management and control options in the Mississippi River Basin and the Gulf to reduce these issues. In conclusion, I believe that to really address this issue, action must be taken higher in the watershed to work to improve water quality of the tributaries that lead into the Mississippi River. Effective solutions can only come by way of a top-down approach as it refers to the stream order of water that flows into the Mississippi River Basin. Federal regulations and funding to support projects relating to the proper management of nutrient application is the most effective way to combat this issue. Not only is this an issue of those living on the coast, but everyone within the Mississippi River Basin. And I believe it will take everyone's help to combat the issue.